Hello, students. So this is Smart Kids Learning Center, the tutoring class. And this is our online class contact number. And we are majorly tutoring all the high school math, specific for advanced function, calculus, as well as English, help students do school homework. The first class is free online. Please contact number to book it. Today, I'm going to teach you for a Gr.12 function book for Hill-Ryerson. So if you have the same textbook, please open to page 78 for Chapter 1 test. Today, we are going to do Chapter 1 test. Page 78, Chapter 1 practice test. Question 1. So which statement is true? For those that are false, provide a counter example. Number 8. All odd degree polynomial function are odd function. Don't you think? Yeah, this is F or true. So I'm going to write question 1 here. So for A, this is going to be a 4. So why this is a 4? So I will explain it to you to an example. So if I'm giving you an example, y equal x exponent 3. And then add x exponent 2. So this is if odd degree and even degree combined together. So therefore, for all the odd polynomial function, odd function is wrong. There's even degree inside. So therefore, we mark it F. Now for B, so we are going to read the question. So even degree polynomial function have an even degree of x-intercept. So is this true? No, it isn't. So the x-intercept doesn't limit to even degree, even number intercept. Like for y equal x exponent 2 quadratic can be have only one intercept at the origin. So therefore, we are going to mark it F. We give an example. Y equal x exponent 2. So if I plot the small graph here, they only intersect at the origin. 1 point. It doesn't mean exponent 2 have 2 intercepts. So therefore, we mark it 4. Now we are going to do C. So we continue move for C. So odd degree polynomial function have at least one x-intercept. Is it correct? It's true because odd degree is opposite behavior. So therefore, we mark it true. So for example, y equal x exponent 3. So we can plot a small graph here. So the graph is going to be in the third quadrant and 1 quadrant. It must be at least one x-intercept. That's true. Now, the next one we are going to do is a D. So all even degree polynomial function are even. That's 4. Like even degree polynomial function, it doesn't mean it's an even function. So let's use an example to prove it. So if I have a y equal x exponent 4 is even leading degree, and then add x. So exponent 1. So therefore, this function is not even degree and not odd degree because they combine. Odd and even are combined. So therefore, F is a false statement. Now we're going to do question 2. So for question 2, which statement is true? So if not true, provide counter example. Now for A, a polynomial function with constant third difference has a degree of 4, which is 4. So if it's a third constant, it will be exponent 3 for the third. So therefore A. So we are going to mark it 4. So we're going to provide an example like y equal x, so exponent 3. So it's an example for a Q, like if it's exponent 3 will be the third difference, consistently no change. Now for B. So question 2B, a polynomial function with a negative leading coefficient may extend from quadrant 3 to quadrant 4. So is this true? Yes. If it's an even degree, leading even. So we're going to put B. It's a true. We are given an example. So y equal x exponent 4. So if y equal x exponent 4, so would it be, would it be going to be a 3 or 4? Yes, if you put the negative leading. So the graph will be like that. Like 3 and 4. So that's how to explain it. But we don't need to do example because it's a true. But anyway, I want to explain to you that's the way to understand it. And number C. So what is the statement for C? We continue read. So 2C. So for a power function with even degree have a point symmetry. So even degree is line symmetry. So therefore C is a 4. So you can put y equal x exponent 2. So it's a line symmetry. So if y equal x exponent 3, it's a point symmetry like that. So that's an odd degree. So only odd degree has a point symmetry, rotational. Now we are going to do the last one for a 2. So 2D. A polynomial function with a 4x-intercept has a degree of 4. Is this true? No. So the intercept, it doesn't present the degree. Let me show it to you. So for a D, we mark it A first. So if I give you an example, so y equal x minus 1, so exponent 3, and times x minus 2, exponent 1. So you know x is going to be an exponent 4. So is exponent 4 will have a 4 intercept? No. This is the order of 3, only intercept 1 time. So therefore here is only 2 x-intercept. Like y equal x exponent 4, so 2 intercept. I write short form. So this example to prove the statement D is a 4. Now we are going to do question 3. So which statement is true or false? Provide example for 4. So we're going to do question 8. So a vertical complex of a factor of 1/3 is the same as the horizontal stretch of a factor of 3. So it's the same. No, it's not same. Vertical and horizontal, they are not the same. So therefore, we're going to put in question 3, A. So we're going to answer 4. And we are going to give an example to prove, like y is equal 1/3x exponent 2. So this is a k. It's not equal. So y equal 1/3 and x exponent 2. Yeah, and 1/3x exponent 2. So they are not equal. So this one is a k horizontally for stretch by a factor of 2. This is vertically compressed by a factor of 2. Good. So that's how it is. And question 3b. So we're going to do when applied, transformation, translation are applied before the stretch and the compress. So it's 4. So when you apply the transformation, you always do stretch and compress first. So that's how we explain it. So translation is not the first one. So therefore, we're going to write B here. So it's the form. So we are going to write stretch and compress first. So that's how we answer it. Now we are going to do C. So what's the answer for C? We move on for question 3C. So C is stretch must be applied before compress. So as for neither, because it really doesn't matter which one comes first. So you're going to put does not matter. Now we are going to do D. So what question D is? So D is going to be a negative k variable. So in this formula, transformation formula, result in a refraction in the x-axis, which is wrong. So it's 4 because k is an x. When k negative, it's refract over the y. So that's how we answer it. So we're going to put 4. So refract on y. So x negative refract on y, y negative refract on x. That's how we answer it. Now we come for the last question in question 3. So the equation for transformation formula here. So can be written in the form. So is this correct? Yes, this is the transformation formula for any type of parental function. So therefore we write Ch. So Ch, we don't need to write any of the example to prove. Let's look at the next question. Now we're going to do question 4 for each group of the polynomial function with the corresponding equation. And we're going to choose the first one first to match the graph. So f and x equal -3, x exponent 3, x7, x8, 1. So for the parental function, it's y equal -x exponent 3. So I'm going to write here. So it means y equal -x exponent 3. So we got to match the graph here. So this is the exponent 3 equation. So therefore we match it for a. So I is for a, so we write a on top. Now the next one is x exponent 5 is a positive leading. So we're going to write this is an odd degree positive leading from 1 to 3rd. So we're going to match for C. Now, and then for the P and X is a Y equal negative X exponent 6 is an even degree negative. So therefore, it's open down. Open down is a B. So that's how we match it for question 4. Now we are in a question 5. So for each polynomial function in question 4, answer the following. A, which finite difference are constant? So we are going to look for the first equation in the question 4. Negative 2x exponent 3, the leading exponent 3. So therefore 5a, we are going to put is a third. So and then for a b, so you're going to find the value of the constant, the finite difference. So if 5a, so we're going to find the difference. We know the a is equal negative 2. So the formula, so a is equal the constant difference, and divide the degree, the leading degree. Victoria. So now we know that a is negative 2. So we put a is negative 2. The constant difference, we don't know. We just put CD in a short form. And the leading degree is a 3. So 3 times 2 times 1 is a Victoria. So now we're going to solve for CD. So CD is negative 2 times the 3 Victoria is equal C and D. Now C and D is equal negative 12. So if for question B. Now we are going to do C. Now what question C is asking? So identify any symmetry, verify your answer algebra. So we're going to identify for exponent 3. So we're going to put I and II. I mean 1 and 2 is the point symmetry. So and then for the odd degree, so for odd leading degree. Now, how about the line symmetry? So for even degree, even leading degree. So that's how we explain it. Now, we finish the question 5. Now, question 6. A quadratic function has zeros -1, 0, 3 for order 2. Number 8. What is asking? Write an equation for 2 distinct functions. Satisfy the description. So we're going to write it here. So the first one. So y equal like 2x and x at 1. So the first x is 0. The second one is a -1. And x minus 3 is order 2. So it's going to be 2, 3, 4. So it's an even function. Now the next one, I can put -2x. X at 1, x minus 3 exponent 2. So one open up, one open down. So we have two distinct, just find this description that pass through the point. So we're going to have a point is 2 and negative 18. So if we want to get the point to satisfy the equation, I'm going to put it for the first one. So if the first equation, y equal a times x, so x at 1 and x minus 3 exponent 2. So I'm going to plug in this point to find the a, and this point must be inside this equation. So I plug in negative 18 for y equal to a times 2, and 2 plus 1, and 2 minus 3 exponent 2. So we're going to get negative 18 equal to a. The value here will be 3 and a 1. So, and then a equal how much? So a is going to be negative 18 divide. So 2 times 3 is a positive 6. So a equal negative 3. So at this point, it will be happen in this equation. The equation will be y equal negative 3x and x at 1 and x minus 3 exponent 2. So the point 2 and negative 18 will be inside the equation. That's for B. So to plot this graph, so we are going to write all the zeros. So x equals 0, negative 1, and a 3. So the y-intercept, it will be at the origin. So, and then we are going to plot here. So negative 1 here, the origin here, and 3 here. So the y-intercept is at the origin. And we're going to plot 2 and negative 18. So 1, 2, negative 18, yeah, somewhere will be here. So we're going to plot from the x-intercept and then move to the y-intercept and then going down. And then move up and touch 3 lightly, very light, white here, because it's the order 2. So we're going to have the point here for around 2 and negative 18. So we have an x-intercept and a y-intercept. And that's how we plot it. Now, and C is also asking you, find the interval that's increase and decrease. Now we're going to find interval positive is for increase. So we're going to write positive x interval. So you can see it's only from negative 1 and 0. So we're going to write negative 1 and 0. So this is a positive function. It's increase. We're going to put an arrow going up, increase function. Now negative function for the x interval, we have a few. So from this part, negative infinity to a negative 1. So we put negative infinity and then to a negative 1. So decrease. And the next one, it will be from 0 to 3. It's also decrease and negative. So I put 2 points. So and then from 3 to infinity is also negative y. So you're going to put x. And that's how we finish for question C. Plot the graph and write the interval increase and decrease function. And we are going to do the next question. Question 7. Determine an equation for the polynomial function that corresponds to this graph. So first, we are going to find all the x-intercept. So it's equal -1, 0, 1, and 2. So, and then the next one we are going to find is how many curves. And you know, it's from the second to the 4. It means it's an odd negative leading. So we count the curve. 1, 2, 3, 4, 5. And we know it's 5, 8, 1. We get 6. And that's the y touch point here. It will be order 2. So we're going to write the parenthetic function. Y equal -8. Now, the next question is question 8. We are going to do identify the parameter for these A, K, D, C for this formula. So for inside the bracket is X movement and Y movement only A and C. So we're going to identify what are they. So, and then also describe each parameter's transformation based on y equal x exponent 4 for this equation. So, and that's for the A. So let's start to do it. So that's for A. So we write A equal 1/3. So, and then we're going to write K. K equal -2. So, and then we write H. H equal -3. And we're going to write C. So C equal -1. So that's A, K, H, and C for y equal x exponent 4. So we finish for A. Now let's do B. Now we're going to write the domain. So for D, so X is element of real numbers. So, and then we write the range. So Y is element of real numbers. And we're going to write a condition. So such as a Y. So this is a positive function. It's going to be larger or equal -1. We're going to write the C value here. Now we're going to describe each transformation. So let's write the A. So it's going to be, so it's vertically. Vertically for fraction is complex by a factor of 1/3. So we finish for A. Now that's for A. So A equal. Now we're going to write K. So K is horizontal. So it's horizontally. So it's a whole number. It's going to be a complex. So by a factor of 1/2. So why is 1/2? Because x divided by 2. That's the transformation formula. X/k. Or I write k. You know k equal 2. Then you know it's a formula. X/k. Now it's negative and refract on the y-axis. So k is negative. Now we are going to write h. So it's horizontally. So it's going to be -3. Shift it to the left. Three units. So 3 units to left. Good. Now the last one is a C. C equal -1. So it's vertically. Shift down 1 unit. So now we finish B. We are verbally described. A is compressed and K is compressed and refract over 5. And H move to left and C move down. Very good. So we are going to do C. Now, question C, describe two possible orders in which the transformation can apply to the parented one, y equal x exponent 4 to produce this graph. So it can be vertical axis. So you're going to write two of them. So, or you can apply, shift it to the, we're going to make it short. Shift it left for 3, shift down 1. Okay. So you're going to write vertically compressed. So, and also horizontal. Compressed. So that's two functions apply for transformation here. So, and then what are we going to do for a D? You're going to sketch the function. And then for the parented one as well as the transformation one. So we're going to plot it. Exponent 4 minus 1. So we will write the equation here. Now to plot the graph. So first, we're going to write the vertex point. So it will be -3 and -1. Now we're going to write the y-intercept when x equals 0. So y-intercept, I put short form. So you're going to write y equal 1/3, -2, 0 at 3, exponent 4 minus 1. So for the y-intercept, so what are we going to get? So we're going to plug inside the calculator. And let me get it quickly for you. So it's equal 431. So the y-intercept point 0 and 431. It won't show in the graph because it's too big. So now we're going to find x-intercept. So we're going to make y equal 0. So first, we're going to cancel -1, move to the other side, will be +1. Now, divide by 3. So multiply will be divide by 3. Divide by 3, we're going to reciprocal will be times 3. So now we're going to cancel the exponent 4. Then you use a large bracket. So exponent 1/4. Now we cancel it already. Now we're going to put this side. So this side is going to be -2x and then -6. So with distribution, solve the bracket. Now we solve 1/3 exponent 4. So let's get this side C equal how much? So if we have a 3, So I'm going to use a calculator. 3 exponent 1/4. So we're going to get 1.32. So this will be positive and negative. So positive and negative 1.32. So we move 6 here, will be at x6. So x will be, we're going to have 7.32 divided -2. So we're going to get the next. We have 2 x-intercept. One is -2.34 and 0. The next one, -3.66 and 0. So we have everything we need to plot it. Y-intercept, x-intercept, and vertex C. So the next page, we are going to plot the graph. So you can draw table 2. So x and y, if I write this, y equal x exponent 4. And how about this one? It's a transform, x over k and -3. So how about y? It's 1/3 times y minus 1. So if I have a 0, 0, 1, 1, 2, it's 16. So how about we apply 3 points here? So it will be -3 and -1. So how about 1? It will be -3.5. How about 1? So it will be -1 minus, okay, I'm going to put 1, subtract 1/3. So it's 0.67. So how about a 2? So 2 is -1. So we're going to have a -4. And 16 divided by 3 and -1. We get 4.3. Now you can use a table to plot it. You can do that. Now we plot the equation here. We get the x-intercept first. So we have a -3.6 here. Excuse me. The next one will be -2.34, 2 x-intercept. The vertex C is -3 and -1. So we have a -3 here and -1 here. So we put the point here. So the pair, we're going to plot it. The y-intercept is very, very up there. And how about the parented one? The parented one will be here in the object. So that's the vertex C, -3 and -1. So that's how we have done for question A, the last part. So finish the graph. And we still have, part of we finished the test up to question 8. And from 9 to question 15. So I'm going to put it for the next video since it's too long. So, and please, continue practice the test and try to get as perfect mark as you can. And this McGraw-HRyerson Learning Center tutoring class. And please subscribe. Thank you. Bye-bye. See you in the next video.